Kids, time to do optimization. This is our last application of derivatives. So our last objective before our unit test. So I want you to actually read this objective. Firstly, set up. That's the hard part you found from related rates. Set up. Solving isn't really going to be hard for you as long as you can set up the problem, because you're going to solve using the first or second derivative test for extrema. So old news, and you're good at that. But it's the setup that takes some pre-cal and some geometry that's going to give you most of the problems, most of the issues with this objective. So you want to do or have the optimization packet out with you while you're doing this, because that's I'm going to get all the problems from the packet, so you can do it along with me instead of copying down the problem. So here we go. You ready? This is a classic fence problem. So somebody gives you some stuff. They want me to enclose geometry. What is the maximum area? Okay, so in my thought, what I want to do, and notice what I've already drawn over here, I'm going to draw every time they want me to maximize something or minimize something. This is an optimization problem, and I need to do the first or second derivative test. So my goal is to get an equation for area. Get an equation for area of that geometric figure, and then do a derivative. So oftentimes I draw myself a picture. This is a terrible picture, right? Look, here's my barn. And then I draw 40 feet of fence. So I make a rectangular garden. Notice that I don't need fence along the side of the barn. So the only taking up the 40 feet of fence are 3 sides of a rectangle. I know what area of a rectangle is. Area of a rectangle is length times width. You want to write an equation in terms of x. Get an equation in terms of x so that you can take a derivative. So I chose to call the width x. So think, if you have 40 feet in total, right? 40 is your perimeter. But for my perimeter, I only need 2 sides and 1 length. But I can't have this length in terms of y. I need an equation in terms of x only. So how can I write this length in terms of x? Well, look at what I have here. My perimeter is 40 is equal to 2 x's plus that length, y. Well, what is y then? So notice I now have the 2 sides and the 1 long length in terms of x. Yay! Why do I care? Because the area of any rectangle is length times width, and now I have both of them in terms of x. So there's my area, no calculus. Area is width times length. I'm going to go ahead and multiply that out. Then I'm going to take its derivative, right? I know that this is a parabola that opens upside down. I can find its max. Hello, there it is. I can find the max. But on an AP calculus problem, on an AP calculus test, you're supposed to use calculus to find maxes and mins. This would be on a non-calculator portion because the numbers are also nice. I set the derivative equal to 0, and I found the x coordinate that makes the derivative equal to 0, and I went to my number line. Now notice on my number line, I have ends. Should this be a closed interval or should this be an open interval? Right, now think, what is the length of my interval anyway? What do I have? What number is up here? You only have 40 feet of fence, right? So you're going to start at 0, which is not really an endpoint, right? Because you're not going to use 0 fencing to make a rectangle. And then what's over here? Remember, x is a side. X is a side. So if this is going to be a prime of x, this is going to be a of x. What's the longest x can be? Is it 40? No. Remember, how many sides do you have? Right? The longest side you can have is 20. Then, of course, I have my suspect when the first derivative is equal to 0 or does not exist. So remember, suspects come every time you're doing a derivative test where your first derivative does not exist, where your first derivative equals 0, and endpoints. So there's my zero and 20. This is a of x and this is a prime of x. What was true at 10? At 10, the derivative is equal to 0. My derivative is a linear function with a negative slope. So the range is positive before the x-intercept and negative after the x-intercept, which means my function is increasing from 0 to 10 and decreasing from 10 to 20. Hello, I already knew that. Duh. But I have calculus to explain it. Now, unlike when I was just giving you a random function and asking you to find max and mins and justify, you don't need to write out a sentence here. You just need to show me your number line work. Because a continuous function is increasing and decreasing, changing from increasing to decreasing, I've passed through a max. If you were to examine the endpoints, right, the first derivative is positive, so you're increasing from the left endpoint. Here, the first derivative is negative, so you are decreasing to the right endpoint. But in reality, 0 and 20, you're not going to use both ear lengths to be 20. Otherwise, you don't have a width. And you're certainly not going to make both sides equal to 0. So I really just needed this interior discussion and then answer the question. Right? What did they ask me? What did they ask me for? They want the maximum area. So go back to the area function and put 10 into it. So there's my 10. I don't need to see all of this calculation. Sometimes the problem asks you for the dimensions, which is why I put a box around this. This one didn't. It just asked me for the area. But if they give you units, you give them units back. And it's area, so it is square feet. Congratulations, you just did your first optimization problem. Woohoo! I used the first derivative test on an open interval to do this optimization problem because they asked me for the maximum area and the endpoints didn't make any sense. Right? So I used the first derivative test on an open interval. So let's kind of wrap up our thought process there. To solve an optimization problem, the first thing you want to know is what is it you're trying to maximize or minimize? It's one or the other. If you see those words, am I trying to maximize or minimize? And name that variable, usually X. Is it area? Is it cost? Is it something else? Once you find out what you're trying to maximize or minimize, you need to write an equation. This is the step that causes kids problems. This is the setup step. And you only want to use one unknown. If you've chosen X here, you want your equation to only be in terms of X. If you have multiple, like I did with area, length, and width, I rewrote one in terms of the other. Sometimes that takes some pre-cal skills. Then finally, you're going to get to the calculus. Use the first derivative or second derivative test for extrema. You are trying to maximize or minimize. So you are looking for extrema, not concavity, right? You are looking for extrema to locate the max or minimum. Remember, you are looking for the places where the derivative is equal to 0. First derivative is undefined. And endpoints if they are appropriate. Okay, let's do another one. So in your packet, you just did number 1. This is number 2. Please put a star next to this. AP, and therefore we, love this kind. And I'm also going to tell you that I'm going to choose. No one's going to make you. I choose on this one to use the second derivative test on an open interval and see if you can see why it's an open interval. Whoops, sorry. So a rectangle, there's my geometry, has its base on the x-axis. And its upper 2 vertices on a parabola. This parabola opens down and has a y-intercept of 12. What is the largest area? Area of a rectangle. And what are its dimensions? So when I am done, I am going to answer an area question and dimensions question. So I've drawn the parabola, now I have to draw the rectangle. So the rectangle has its base on the x-axis and its upper 2 vertices. So I have a base on the x-axis, and if it's a rectangle, right, this side has to be the same height as this side, and that's only going to happen if I'm on a parabola. It's only going to happen if I am symmetric with the origin, right? This parabola is even. It's symmetric over the y-axis, so a rectangle is going to look like that. That is under the parabola. Now, since I want area, I want to maximize area, I need an area equation. And then I need the area derivative. But I need the equation in terms of only one variable. So let's look at this rectangle. What length is that right there? What length is that? Isn't that x? What's the height? Y, isn't it? So this point on the parabola, xy, the height is y. Is the width x? I don't think so, is it? The area is not x times y. Right? because this is not the whole length of the rectangle. How long is the rectangle? Isn't that 2x? Now, I can't have this situation. I need to be able to rewrite the height in terms of x. Can you see how I can do that? How do I get this height? Its vertex, the vertice on the rectangle is on the parabola. What's the height of this rectangle given that x is the width? I went out x. How far am I going up? Y. What is y? Right? So my area equation is, there's the base or the length, not just x, twice x, and then y. Nice, right? This also would be on a non-calculator part. I can tell by how nice the numbers are, because my area equation looks like that. Now what do I do? So I have the area equation. Now take the derivative. Now I could set the derivative equal to 0 and do a number line test, but I want to model using the second derivative test. Right? So I'm going to use the second derivative test. And again, I have an open interval because they want to know the largest area, right? So where is the first derivative equal to 0? Right? I'm going to divide everybody by 6. Going to get x squared is equal to 4. And then x is equal to plus or minus 2. Since I'm talking about the length of a rectangle, I don't need the negative. So I am going to take my suspect to the second derivative. So I already know I have a horizontal tangent at x equals 2. What is the second derivative at 2? Negative 12 times positive 2 is negative. Therefore, concave down. So at the same x, if you have a horizontal tangent and you are at the same time concave down, you must have passed through a max. Therefore, my suspect has been convicted. I was asked for the maximum area. Area is equal to 2 times x times 12 minus x squared. Two squared is 4. 12 minus 4 is 8. 8 times 4 is 32. They didn't give me any units, so I don't have to give them units back, but these would be their area, so they would be square units. And my dimensions, the length doesn't equal 2, does it? What is the length of this rectangle? It's not 2, it's 2 times 2. And the width is 12 minus x squared. So I get 4 and I get 8 linear units. Okay, so again, I didn't want to, right, I could have, just like I did the first problem, I could have done the first derivative and made a number line test, but I just wanted to model both using the first and second derivative test for extrema. All right, that was number 1 and 2 of your big packet. Skip over to number 5. I'm going to use the second derivative test here as well for extrema. So I have 2 sides of a triangle. There's my geometry. Lengths A and B, and the angle between them is theta. So I'm thinking triangle and an angle. What value of theta, so this is my variable, will maximize the triangle's what? Area. So I want an area of a triangle equation, and then I want to take the derivative of that area. So A and B are, so I have some triangle with the sides A and B, they're fixed. And I have this angle theta between them. So you do need to know that the area of a non-right triangle is 1/2 times its sides, the product of its sides, times sine of the included angle. If you needed that formula on the AP test or our test, we would give that to you. I would never give you 1/2 base times height, but a non-right triangle, I would give you this formula. But the important thing to know here is that this is a constant. I don't have 3 variables here. A and B are sides of the triangle that are not going to change, right? The lengths of the sides are not going to change. So I just have area is equal to a constant sine theta. So there is my equation. Now I just need to take its derivative. What is the derivative of a constant times sine theta? That constant times cosine theta. Set the derivative equal to 0. Make sure you do those 2 things at least. Find an equation for what you're trying to maximize or minimize. Take a derivative and set it equal to 0. I'm trying to solve for theta, so divide both sides by this constant. When is cosine theta equal to 0? Again, we're in a triangle, so right, we're going to go between 0 and pi, right? What's the second derivative? I don't have any problems with differentiability. There's my suspect. I'm going to take my suspect to the second derivative. Constant times cosine theta is negative that constant times sine theta. And I put pi over 2 in there. Sine of pi over 2 is 1. 1 times A and B are lengths of a triangle, so they're positive, times a negative. Horizontal tangent, because the first derivative was equal to 0. Second derivative is negative, therefore concave down. Therefore, I must have passed through a maximum. So what value of theta when theta is equal to pi over 2 or 90 degrees? And since you're in a triangle, you want to answer degrees, that would be fine. And this should make sense. All right, so those are just a couple of optimization problems in this packet. In the next video, we'll go through some more, and the other ones that we're going to go through are a little bit more mathematically challenging. Not really, as long as you get that set up and realize that what I have to do is get an equation in terms of one variable, take a derivative with respect to that, right? That variable, and do the first derivative test with a number line or the second derivative test with concavity to find your max and min. Okay? You don't have to write a lot, not a lot of words in here. Just answer the question with units if they give you units. All right? And we'll do some, talk about some optimization in our live session as well. All right, I will see you then.